Computer organization and architecture. Addressing modes. There are 11 types of addressing modes to be discussed. So let's have a look on each one of them. First one, implied addressing mode. In this addressing mode, the definition of the instruction itself specifies the operands implicitly. So it is also called implicit addressing mode. Example, in a stack organized computer, 0 address instructions are in implied mode. Why? Because its operands are always implied to be present on the top of the stack. Second one, immediate addressing mode. In this type of addressing mode, the operand is specified in the instruction explicitly. Example, add 10 will increment the value stored in the accumulator by 10. Just like that, move R #20 initializes register R to a constant value 20. Third one, direct addressing mode. In this addressing mode, the address field of the instruction contains the effective address of the operand, and only one reference to memory is required to fetch the operand. It is also called absolute addressing mode. Example, add x will increment the value stored in the accumulator by the value stored at memory location x. Fourth one, indirect addressing mode. In this addressing mode, the address field of the instruction specifies the address of memory location that contains the effective address of the operand. Example, this is shown below, just check on it. Fifth one, register direct addressing mode. In this addressing mode, the operand is contained in a register set, and the address field of the instruction refers to a CPU register which contains the operand, and no reference to memory is required to fetch the operand. Example, add R will increment the value stored in the accumulator by the content of register as shown here. Check it. And there is a note here to be noted that this addressing mode is similar to direct addressing mode, and the only difference between them is the address field of the instruction refers to a CPU register instead of M. Sixth one, register indirect addressing mode. In this addressing mode, the address field of the instruction refers to a CPU register that contains the effective address of the operand. So here the effective address contains in the CPU register, and only one reference to memory is required to fetch the operand. Have a look on the example shown here, and there's a note that this addressing mode is similar to indirect addressing mode, and the difference is that the address field of the instruction refers to a CPU register. Seventh one, relative addressing mode. In this addressing mode, effective address of the operand is obtained by adding the content of the program counter with the address part of the instruction. Again, by adding the content of program counter with the address part of the instruction. Note, program counter or PC always contains the address of the next instruction to be executed. So after fetching the address of the instruction, the value of program counter increases. The value increases irrespective of whether the fetched instruction has completely executed or not. Eighth one, indexed addressing mode. In this type of addressing mode, the effective address of the operand is obtained by adding the content of index register with the address part. Ninth one, base register addressing mode. In this addressing mode, effective address of the operand is obtained by adding the content of base register with the address part of the instruction. 10th one, auto increment addressing mode. This addressing mode is a special case of register indirect addressing mode where effective address of the operand is equal to the content of the register. And in this addressing mode, after accessing the operand, the content of the register is incremented, automatically incremented by size D. And it depends on the size of the operand. D depends on the size of operand. So the last one, auto decrement addressing mode. So it's obvious that it is opposite of the auto increment addressing mode. And in this addressing mode, first the content of the register is decremented by step size D. And what does step size D depends on? It depends on the size of operand accessed. And after decrementing, the operand is read. And only one reference to memory is required to fetch the operand. So this is it about the topic addressing modes. Hope you all understood. Thank you and have a nice day.